Hi guys, it's Mrs. Millicent. Let's go over the Check You Understand on page 116. You know, write that down. Okay. We are going to learn how to use our table and our calculator to figure out area under a curve based on a z-score. Okay. Let us recall that in a density curve, the area under the whole curve is 1 or 100%. So we're going to learn how to find the area to the left of a certain point, to the right of a certain point, and between two certain points. Okay. Here's zoom in on this. Okay, so for the first one, we're going to do find the area under the curve that is less than a z-score of 1.39. Okay, let's recall up here. Let's recall that we denote a normal curve with its mean and standard deviation. So a standardized normal curve, has a mean of 0 and a standard deviation of 1. So if we think about it in terms of our, drawing, we have our mean of 0, and then we have 1, 2, 3 standard deviations above the mean, and 1, 2, 3 standard deviations below the mean. So these down here will be z-scores, okay, that associate how far away above and below the mean the item is. These z-scores are negative, these z-scores are positive. This is above the mean, this is the below the mean. Okay. So the first one we're going to do, find the area under the curve where z is less than 1.39. Okay, first things first is we're going to draw a curve. Oh, I have a stamp. I should use my stamp. I'll use the stamp on the next one. So this is 0 at the mean. So 1 standard deviation, 2 standard deviation. So 1.39 is probably going to be right around there. Okay? And we want the area less than it. So we're going to shade this way. Okay? All we have to do is look on our z-table. Our z-table will tell us. If we look up the z-score 1.39, it'll tell us what this area is to the left.
Perfect shading.
Be quiet. So the z-table's in the back, and I'm going to show you the z-table because the book references it, but we're not going to use the z-table. We're going to use our calculator. But in the back of the book, you have standard normal probabilities. It's got z's. That's how I know it's a z-table. One side are your negative z's, which is to the left of the mean. The other side are your positive z's, which are to the right of the mean. Okay, so we're doing 1.39. That's to the right of the mean. So 1.3, right? And then up here to 0.9. So 0.91. You with me? 0.9177. Right? So 0.9177. So this area to the left of the curve is about almost 92% of the curve, okay? If we think about within 2 standard deviations, the mean is 95% of the curve. That makes sense, okay? So we can also say this is about 91.77% of the data. Now, I also want to show you how to do it in the calculator because we're going to be doing it in the calculator, okay? Turn the calculator on. We're going to hit second and then vars. And you've got normal CDF. CDF stands for cumulative, okay? So our lower bound, what is the smallest number that's being shaded? Now, the shading goes on forever. So the smallest number is -1 times 10 to the 99th. That's like the smallest number that we could possibly think of. What's your upper number? The upper range is, or the right, the highest number that's in the shaded is the z-score of 1.39, okay? Our mean is 0, and our standard deviation is 1 because it's a standardized normal table or normal graph. And there's our area, 0.9177. So it gives you the same thing as the book, but a little faster. Or same thing as the table, but a little faster. Okay, number 2 says, find the area where z is greater than -2.15. So again, we're always going to draw our curve. Here's my mean of 0 in my standardized curve. So there's -1, there's -2, there's -3. So -2.15 z-score is way over here, okay? And I want the area greater. So I'll shade this a little better. I want this area over here. It's
so much worse.
It's practically 100%, really, you know? I mean, it's almost at -3 z-score, so it's practically 100%, okay? So let's look at the table. -2.1. I'm going to hold my page. -2.1 and then 5. Where am I? So 0.0158. You with me? Did I do that again? 0.0158. Go back up. So there's the 0.05 and there's the 2.1. So 2.15. Okay? 0.0158 you said? 0.0158. But that's only, what, a little less than 2%? That doesn't make sense. Well, the area on the table is the area to the left of the curve. So this area, this proportion is 0.0158. So this is about 1.6%. Yeah, so we can either do 1 minus or 100 minus 1.58. Whatever. We get 0.9842 or 98.42%. Okay, but we're going to do it in the calculator. Okay, so back to our second vars, normal CDF. Now, what's the smallest number on the left? It's not a huge negative number. It is negative 2.15. Okay, now this goes on forever. Come to my curve. So there's my negative number, negative 0.21. My smallest negative number, negative 2.15. But my largest, it goes on forever. So come back to the calculator. So I just have to type in, oh, you got a glare. The largest number I can think of, so I'm just going to put 1 and as many zeros as it takes for me to talk. Okay, and we got our mean of 0, standard deviation of 1, and I paste that in, and lo and behold, we get the exact same thing. Gotta love it. Okay, everybody good? All right, number 3 is the area between two z-scores. Okay, so there's my 0. Let's put my 1, my 2, my 3, 1, 2, 3. So negative 0.56 is about here, and 1.81 is about here. Okay, so I will shade between those two. Okay, so in order to do this, I gotta look up both of these on the table. Okay, so negative 0.56 is 0.2877. Yeah, so that's 0.2877. And then 1.81, here, follow me here. 1.8, where am I? 1.8 and then 1, right? 0.9649, okay. 0.9649. So if you think about it, remember these areas are from the point to the left of the curve. So all of this is about 96.49%. All of this is 28.77%. So if I take that and subtract that, it gives me my difference. So I get 0.9649 minus 0.2877, and that'll give me a difference of 0.6772. So it's about 67.72% of the data is between those two z-scores. Okay, a little cumbersome using the table, but in the calculator, it's so quick and painless. So second vars, normal CDF. My lowest possible value in the shaded area is negative 0.56. My largest is 1.81. Standard deviation again is, mean is 0, standard deviation is 1. Paste this, and I get my answer. A little difference, you know, a little difference with the rounding, but whatever. Okay. Is everybody good? You good? Okay. All right, the last two things, we're going to use table A to find the value z from the standard normal distribution that satisfies each of the following conditions, okay? This time, we're looking at the percentage of data that's underneath the curve, and we have to find the matching z-score. Before, we were given the z-score, and we had to figure out the matching area, or we had to find the matching area. So we're going to do the 20th percentile, okay? So let's find the z-score that associates with the 20th percentile. So let's figure out where this is on the curve. So here's my mean. All right, where's the 20th percentile? The 20th percentile means it's a point at which 20% of the data is less than that point. So it can't be over here because this is 50% and this is greater than 50%. It's got to be over here. So I don't know, somewhere around there. So this is 20% of the data. So we have to find the associated z-score with that area. So we can't look up the z-score on the edge of the table. We're going to look in the guts of the table for the area. Now, of course, area is all in decimals, so we have to look up 0.2000 in the guts of the table. Now, obviously, it's going to be a negative z-score because it's on the left side, okay, of the mean. So here we are on our negative z-scores. We got to look up 0.200. Okay, I've got these two. Zoom in on them, okay? So which one is mathematically closer? Not greater than or less than, but mathematically closer. This is only, what, 5 units away, and this is what, 23 units away? So this one is actually mathematically closer. You with me? Okay, so let's see. Let's zoom out so we can see what z-score this associates with. So this associates with negative 0.84. Okay, so that has a z-score. Negative 0.84. So there's really no work to be shown. Okay, let's do this.
You should squiggle things. It's not exactly.
Oh, it's close enough. Let's do this on the calculator. Okay, this is not normal CDF. Here, show so you can see this too. This is not normal CDF, but if you go into second VARS and you go down to inverse norm, it'll show you your z-score. So here, now in your calculators, you won't see left, center, and right, okay? And I will just keep it as left. Yours is always left. So what area to the left are we looking at? 20%, okay? You can just put 0.2. I'm just putting the zeros to match what I wrote. Okay, my mean and my standard deviation are still the same, and it's just telling it 20% to the left. Oops. And lo and behold, there's my z-score. Negative 0.8416, okay? Negative 0.84 is fine. You can go to 2 decimal places, okay? Much faster in the calculator after you got your picture. Okay, let's do number 5, last one over here. So 5 says, come over here, 45% of all observations are greater than z. Okay, so I want 45% of all observations are greater than z. So if I'm here, this is 50% is greater. 50% is less. So I want 45% is greater, so I got to move over a little bit. So over here, I've got some z where 45%, I should have made it a little tighter, but whatever. 45% is greater. That's a terrible percent. Okay. Well, if I look on my table, I got to look, but my table's going to show me the area to the left. So what's the area to the left? If 45 is to the right and the whole thing's 100, what's the area to the left?
Want me to tell you?
Yes.
55.
Okay, so this is 55%. That's what we're going to look up in the guts of the table.
We're doing audience participation.
Yes, indeed. Okay, so 0.5500. Let's go look in the guts of the table. Oh, it's on this side, so it's going to be a positive z-score. So come on over here. Let's see, 55, 55. Here we go. I got these. Okay, so let's see. This one is about 17 units away, and this is what?
22.
22. So this one is closer. So the associated z-score, come over so you can see the edge, is 0.13. Is everybody with me? 0.13. Is everybody with me? Nobody's with me. Thank you. So our z, what did I say? 0.13?
Yep.
Okay, so a z-score of 0.13 associates with 55% less and 45% more. One z-score gives you 2 values, okay? So let's do this one in the calculator. But show it so you can see this, so they can see it come up. So second VARS, oops, I did the wrong thing. Second VARS, inverse norm. Again, area to the left. So I'm looking for 45% to the right, but you got to put in the area to the left. So you got to put in 0.55. And again, our mean and standard deviation are the same. And lo and behold, we have to do a little rounding there, but 0.13 is indeed the z-score if you round it to 2 decimal places. Okay? All righty. Thanks. See you for the last one. Bye.